In this video, we're going to continue our series on special types of factoring by talking now about perfect square trinomials. So here's what you want to put in your notes. For any real numbers a and b, a squared plus 2ab plus b squared can be factored as a plus b squared. So here's some things to look for. You have trinomial, so there's three terms. The first term is a perfect square. So this would be some number or some variable squared. The last term is also a perfect square. It can be a number or a letter squared. And once you determine what you squared for this first term, so what we squared for the first term was a, and what you squared for the last term, which was b, take those two numbers or letters and multiply them together. That will give you ab, and your middle term should be twice what you get when you multiply these two. Double, twice. 2 times a times b. So we'll do some examples below so you can tell what I'm talking about. This might all sound like Greek to you right now, okay? All right. So when you have this special case, this trinomial, three terms, the first one's a perfect square, the third term is a perfect square, and the middle term is made up of what you get if you multiply the first times the last, and then double that. Then you are going to know that you can factor that as a plus b, the binomial, squared, where a and b are the things you squared to get the first and the last term. Okay, our next case is the same trinomial. Looks very similar to the top, but the only difference is that your middle term is negative. And so this one you would multiply, or you would factor as a minus b squared. Okay, so we're going to do some examples so you can see what we're talking about. But again, notice that we are going to be having to recognize squares. Now, if you watched our the previous video on difference of two squares, then you know about this little table that we're going to make right here. But in case you didn't, let's make ourselves a table, and I recommend you put this in your notes. And what I'm going to do here is just write down the first 12 whole numbers. So 1 through 12, and then we're going to write their squares below, because that's what we're going to look for, are the squares. So, and let's do that in a different color. So 1 times 1 is 1 squared is 1. 2 times 2, 2 squared is 4. 3 times 3, 3 squared is 9. So you get the idea, right? 16 is 4 squared. 25 is 5 squared. 36 is 6 squared. 49 is 7 squared. 64 is 8 squared. 81 is 9 squared. 100 is 10 squared, 10 times 10. 121 is 11 squared, and 144 is 12 squared. So we're going to be looking for those squares. Okay, so here we go. Let's try. Here we have a trinomial. So we have three terms. Let's look at the first term. Is it a perfect square? Yes, it is. It's a squared, right? You squared a to get a squared. Let's look at the third term. Is that a perfect squared? Yes, it is. It's 5 squared. You squared 5 to get 25. Now, if this is a perfect square trinomial, then this middle term will be what you get when you multiply a times 5. Okay, a times 5 is 5a, and then double that, twice that. So twice a times 5, or 5a, is 10a. So we have the right middle term for a perfect square trinomial. And because we have a negative here, then we know that our factor is going to have a negative, and that this is a perfect square trinomial. So it is a binomial squared to get this trinomial. And what did you square? A minus 5. A minus 5. Okay, so let's see if that checks. Let's do a check here with our foiling. And if you're going to foil, you write this down twice because we have a minus 5 squared, right? Okay, so first, a times a is a squared. Outer, a times negative 5 is negative 5a. Inner, negative 5 times a is another negative 5a. And last, negative 5 times negative 5, which is a positive 25. Now we have some like terms here in the middle. We have a negative 5a added to another negative 5a, which gives us a negative 10a. So our answer is a squared minus 10a plus 25. So it checks because that's the trinomial we started out with. So here's our factored form. A minus 5 all squared. Okay, let's try another one. Okay, again, you need to factor the polynomial. You notice it's a trinomial. There are 3 terms. You notice that the first term is a perfect square. It is x squared. You notice that the last term is a perfect square. It is 36 is 6 squared. Now, to determine if you have a perfect square here, we need to see if x times 6 and then doubled gives us 12x. So x times 6 is 6x. Twice that is, yes, 12x. So that checks. So we do have a perfect square trinomial here, which means that we're going to have a binomial squared, the factor form. And this is going to be x plus 6. So notice we use these same numbers here, x and 6. And it's a plus in between because we have a plus here. Okay, I'll leave the check up to you. Here's the next one. We have, again, 4x squared plus 12x plus 9 is a trinomial. There are 3 terms. This first term is a perfect square. Now remember, here's where your table above kind of is handy. If you have it nearby, well, it's 4 and 9 are on your table, right? Let's look at that again. So see, 4 and 9 are here on your table. And remember, we're always looking at the bottom row for the squares. So again, so you see this 4x squared, and you know that's a perfect square, and it is 2x all squared, right? And you know 9 is a perfect squared, it's 3 squared. And to check to see whether this is a perfect square trinomial, we would need to multiply 2x times 3. So 2x times 3 gives us 6x, and then double that, twice that, 2 times 6x, which is 12x. And guess what? That is our middle term. So when this little test checks, then you know you have a perfect square trinomial, which means that you can factor this trinomial as a perfect square, as a binomial squared. This is a plus, so we're going to have a plus in here, and 2x plus 3. Remember that we are using these two? These come in here, okay? And I want to remind you from our last video that this is the factored form. This final answer is right here. This part right over here where we're just checking the form, that's not the factoring part. Okay, this is just to check that we do have indeed a perfect square trinomial. All right, one more. Okay, this time we have x's and y's, but no problem. We'll just treat them the same. So we have trinomial. We have 3 terms. This first term is x squared. This last term is also a perfect squared. 49 is 7 squared, and we have y squared. So this last term is 7y squared. Okay, now we have to check that our middle term works, that for the perfect square trinomial. And remember how we do that? We multiply the x times the 7y. So that's going to give us 7. X times 7y is 7yx. Or, gosh, let's use a different. X times 7y is 7xy. Remember, we can always rearrange the variables when we're multiplying like that. And then we need to make sure that our middle term is twice this, which it is, right? Twice 7 is 14. This time we have a negative, so we are going to factor with a minus in between, and this is going to be a perfect square, and it's x minus 7y, all squared. So here's our final answer. Okay, I hope you kind of made notes of how we can tell that this trinomial is a perfect square trinomial, because in your homework and your tests, you're going to have all sorts of polynomials all mixed up, and you're going to have to recognize them in order to be able to factor them. So these are some of the tips you want to use in order to be able to recognize which polynomial you have. So look for our next video, which is factoring polynomials, kind of a review. And so we're going to have all these polynomials all mixed up for you to practice, to factor.